Hi, this is Anshuman, and today I want to tell you about how to deploy code. Now, why is it important that we know how to deploy code? Well, every single program that we write could be run completely differently, with a different set of programs underneath it to make it work. For example, if I was writing a React program, which is usually meant for front-end applications like websites and that sort, well, I would need to have React and JavaScript, the underneathing program underneath that, installed. Well, okay, that's not too bad. But what if I also had Python to do some math with it, or MySQL to run database queries, or Java for some backend development, or C++ because I had a specialized engineer, or Ruby because I had it's a lot, right? I have to download every single one of these programs individually onto the server. And if I have 100 servers, well, I mean, good luck with that. And then if there's even one that crashes, you'll have to reinstall everything manually. So hopefully you can see that there is an overall need to have a system that does all of this automatically. This is the purpose of containerized applications. Now, we'll get to what a containerized application really means later on, but here's the overall diagram for it, right? So we have Docker, which creates these so-called containers, and we'll talk about them later. But all of these containers will then go onto a server, right? And this is where this program will actually run. Now, this server is running on the cloud. Now, what does the cloud actually even mean? Well, the cloud is basically just computers that you get for hire, right? You scale them up and down as you need, and they're always available because there's one central place, such as Amazon or Google, who runs all these computers all the time, and therefore they're always up and ready for you to use them. Now, going back to our diagram, these computers, these servers, they exist as you need them. So you can create what's called an auto-scaling group to make them go up and down for you automatically. You don't have to manually click every single time you need a new server. You can just have an auto-scaling group do that for you, right? All of this can be specified using a tool known as CloudFormation. It's basically a scripting tool that allows you to specify, hey, I want this many instances of this kind. I want this many instances depending on what my specifications are, how many requests I get, stuff like that, right? And all of these servers are then run inside of a cluster. Now, this is a bit of a complicated concept, but a cluster essentially hosts a bunch of services. And these services are what run the actual programs, right? So we have these clusters which have a host of these servers, and inside each of these servers, we have the containers. Now, I promised that we would get back to containers in a bit, so let's get to that right now. A container is basically just a singular program that has everything already that it needs inside of it. Now, what does that mean? Well, if you think of an apartment, imagine you're moving in and everything, all your furniture, all your needs, all your utensils are already there the moment you move in. Well, that would be pretty convenient, right? Instead of you moving in and then having to order everything one by one. It would be a lot faster, a lot more efficient, and in the computerized world, a lot cheaper too. So that's what a container is. It specifies everything for you before you even do anything. And this can be incredibly useful when you have multiple different applications, all with different specifications. So here I have an example of what's called a virtual machine, which if you have a computer, you can run a number of virtual machines onto that computer. So here I have one virtual machine, which basically just acts as a computer inside of the computer. And inside of this virtual machine, I have containers, which we just talked about, right? So I might have one program where that's written in Node.js, another that's written in Java, and another in Python. Well, every single one of these is going to need its own dependencies, and therefore they have their separate containers to run their applications on them. So this makes it really convenient if you specify each of these in through Docker, and then you get these images to work for you. Okay, now that I talked about what's going on behind the scenes, I want to address the actual program that I've made to showcase all of this. So here's kind of my code for what I'm calling Spring Boot files. Now, when I start this program, it seems pretty complicated, but what it does is pretty simple. All it allows me to do is send requests to this API and then collect data from it. So if I were to go to this application, which is basically just a usage for testing APIs, well, I can see when I try to get any data, get any topics that I have, I get nothing. And then over here, if I create a topic and I send it this information, well, it stores this information and then it gives it back to me when I once again try to get more topics. And I can view all of this inside of my browser. So if I were to refresh this, well, here I have the Java topic that I just inserted. Well, what if I added this one? Okay, now let me refresh this, and boom, I get Spring now. Okay, that's a pretty simple application, and it doesn't do too much. But that's the idea of it. Now, what if I wanted to package this and run this anywhere instead of needing to have this IDE open and all of this set up? I just want it to run on my computer, any computer, and I just want it to be able to just push up one button and have it run. How would I do that? Well, that's why I have this. This is a GitHub repository, which stores all my files on a centralized service. Now, here I have a Docker file, which if you remember back in the diagram that I had, Docker is what was used to create the containers, right? It creates the actual underneathing lying structure. So here, this is all I really need because Ubuntu already has all the necessary files that Spring Boot runs on. And this is great because it allows me to use other people's images or other people's containers to specify my own, and I can just add my own stuff on top of this. Now, I won't go through what all of this means, but as you can see, it's very simple. And so, just from this, I've created a container that I can run on my machine, someone else's machine, or on the cloud, any number of places. And so, this is a vastly important way in which large companies can run multitudes of applications all at the same time in tangent and have it work wonderfully. Well, I hope you've enjoyed my presentation, and I hope you have a great day.